Okay, now we're dealing with another type of inequality. This one right here is what we call a rational inequality. So for a rational inequality, we are concerned with where the numerator and denominator of the rational is 0. Well, in this case, -4 would never be equal to 0. Therefore, we don't have to worry about this. The only thing we do have to worry about is where does the denominator equal 0. So this is a very simple setup. We say -7x minus 3 equals 0. Okay, so I'm going to add 3 to both sides, and I get -7x equals 3. And then I'm going to divide both sides by -7. Okay, so then I end up with something that looks like this: x equal -3/7. Well, this is nice. It makes my problem now very easy. I'm going to draw a number line, and I'm going to put right here in the middle -3/7. Okay, and it really doesn't matter after that. We just remember here's infinity, here's negative infinity. But right now, this -3/7 is kind of like our midpoint. And what we're going to do is we're going to pick test points on either side of it. So a good test point here is 0. That's something that's after. And then a good test point before, well, -1 is a really nice choice. So here is the other test point. I'm going to draw my line here on my paper. So there are my two test points. All right. And now I'm going to plug in these two numbers into the rational and check which set is true. Where does this value for x make this rational greater than 0? Okay, so let's check right here. X equal -1. All right. Let's check x equal -1, and let's see what we get. So we're going to have -4 over -7 times -1 minus 3, and we're checking if it's greater than 0. This gives us -4 over 7 minus 3 greater than 0. So -4 divided by 4 greater than 0. And let me make this longer. So -4 divided by 4 is -1. And let's ask ourselves, is -1 bigger than 0? Is it greater than 0? And the answer here is that no, it is not. So this right here is a false statement. Now let's just check the right-hand side to see if any point beyond this would satisfy. So let's check x equals 0. And let's see, -4 over -7 times 0 minus 3. Well, this just gives me 0. We're checking if it's greater than 0. -4 over -3, is it bigger than 0? Well, this is a negative divided by negative. 4/3 then is positive. Is it greater than 0? The answer is that yes, it is greater than 0. All right, we know it's a fraction. It's about 1 1/3. But 4/3 for sure is definitely bigger than 0, which is non-negative. This is positive. So we know we're going to actually shade to the right of the -3/7 now. So because it's simply greater than, all I need to do is put the parentheses and not a square bracket, and then I'm going to shade to the right. So here we shade to the right, and there we go. We've shaded to the right, and now what does our interval look like? Well, our interval notation is from -3/7 all the way to infinity based on the sketch here. That's how we can determine it, and there is our solution for this rational inequality.